Hey everybody, another day of radical operations. Today we're going to be looking at radical equations. So we're in section 10.4. This is going to be the tutorial video for that section. Solving radical equations, really cool equations. Get ready for some fun. Let me present. Okay. You should still be able to hear me, and you should have your hand out in front of you. That is going to show up in 3, 2, oh, there it is. All right, let's make sure we're good to go here. Awesome. Okay, so section 10.4 is on radical equations, which means we're going to be solving equations that have a square root sign. And that's all that means. You're going to see something like square root equals something else. Since we're solving equations, just a kind of a reminder, whenever you solve an equation, you have to use inverse operations, or think of them as opposite operations. This takes us back to SADMEP from the beginning of the year. So, for example, if I do the opposite of addition, that would be subtraction. If I need to undo multiplication, the opposite of multiplication would be division. Well, what are we going to add in today that's new? What we're going to add in today is, how do I undo something that has a square root? What's the opposite of taking the square root? The opposite of taking the square root is just squaring. That makes the radical go away. Okay, so to undo a square root, the inverse operation is squaring both sides. That makes the radical disappear. So for example, we've seen this property when we did section 10.2. If I have rad 5 and I want to make that rad disappear, all I got to do is square that radical, and this just turns into a normal 5. So today we're going to do that with like x's. If I square x, now the radical disappears and I just get normal x. So when you solve a radical equation, these are the steps that you want to follow. The first thing you want to do is you want to get the radical, the part that's under the square root, all by itself. So get the square root part alone. Okay, get rid of anything that's blocking it. Okay, so I'm going to do that first. And the one I have here, I have rad 3x plus 1. Notice the minus 2 is outside the rad, and the whole equation is set equal to 6. My job right now is I want to get this radical all by itself. So I'm going to have to add 2 to both sides in order to get rid of the minus 2. So now I've got rad 3x plus 1 equals 8. Second step goes right back to what I said from right here. If you want to get rid of the square root, you got to square both sides. So that's the next thing I'm going to do. Once the radical is all by itself, you got to make sure the radical's alone first. Square both sides, and what that's going to do is that's going to get rid of the radical, and it's just going to leave you with what's underneath. So all I have left on the left side is 3x plus 1. And on the right side, it's not 8 anymore, it's 8 squared. So you got to make sure that you write 64 there. You got to square the 8. And look at that. Now it's just a normal 2-step equation that we solve using tricks from first semester. SADMEP to save the day. Subtract 1 from both sides, get 3x equals 63. And then I'm going to divide both sides by 3. So I get x equals 21. And whenever you're solving radical equations, there's going to be some times when answers don't work. 21 is going to work, so I'm going to show you how to check your answer just to make sure that things work out nicely. But you always want to ask yourself, does my answer work? So what types of numbers cannot be inside radicals? Well, the first thing that can't happen is you can never have a radical be set equal to a negative number. And the other thing you can't have is you can't take the square root of a negative number. So when you're checking your answers, if you ever get to a stage that looks like this or like this, it's not possible. So for example, if you see something that looks like this, square root equals a negative. Anytime you're solving the problem and you get to a step that looks like that, that automatically means the problem doesn't have a solution. You can't take the square root of a number and have it come out to a negative. A square root always comes out to a positive number. The other thing you can't do is take the square root of a negative number. Remember, if we do something like that, square root of negative 36, for example. Uh-oh, is my calculator broken? No, it's just trying to tell you that it's not a real answer. It's called an imaginary number. Okay. Yes, it's like a fake number. And you'll talk about those in algebra too. So for now, we just go with the easy route and say no solution. Okay. So for example, say you had an equation that looked like this. Square root of x plus 1 equals negative 5. This is a silly statement. The square root of anything, didn't matter what I put under here. If I take the square root, This is a no-no. The square root cannot come out to a negative. Okay, so this problem would have no solution. Okay, be on the lookout for this. This shows up quite often, and I can guarantee on some homework problems or on a quiz or test, you're going to get some that look like that. So let's just check the 21 that we got to make sure it works. Here's how I check my answer. All I do is I go back up to the original equation and I plug in the number I got. So I'm just going to plug in 21 for x. So let's just check ours. Check x equals 21. You want to make sure it works. What was the equation? 3x plus 1 minus 2. So I'm just going to plug in 21. And the right side was equal to 6. And then I just simplify both sides, and I want to make sure that I get 6 on the left side as well. So this turns into 63 plus 1, which is 64. And the square root of 64 is 8. Does 8 minus 2 equal 6? 8 minus 2 is 6. 6 equals 6. True statement means that 21 is a solution. I'm just going to circle that and box it. Okay. All right. Let's do some other ones for practice. Pretty much all there is to the first set. We'll get some longer ones in a little bit, but I want to practice some of these first just so you get some practice figuring out how to isolate the radical and how to proceed from there. So here's some examples. The first one we got is rad 5x plus 7, which is outside the rad, equals 17. So my first step, if I look back at my checklist, I need to make sure that I get the radical alone. So I'm going to subtract 7 from both sides. I'm just using the inverse operation. Notice that 5x is still under the radical. Now that I've gotten the rad by itself, I want to get rid of the radical. The way I get rid of the radical is I square both sides. So now all I have on the left side is 5x, no more radical. And remember, you're not putting 10 here, you're putting 10 squared, which is 100. So divide by 5, divide by 5, x is 20. And I'm not going to show the check for this one, but if you were to put 20 back in here and check it, 20 times 5 is 100. Square root of 100 is 10. 10 plus 7 is 17. So you're not going to have too many issues at this point unless you have a rad equal to a negative. We'll see later that if there's some special cases where you have to check your answers a little bit more carefully than these. Okay, so the second one, I have 4 times, you don't see it, but there's an imaginary multiplication sign there. 4 times the square root of x plus 4 equals negative 24. The radical is not alone yet, so I need to get the radical by itself. I see multiplication. The opposite of multiplying would be to divide. So I get rad x plus 4 equals negative 6. I pause and I look at it. I have a square root. I don't even care what's under here. I have a square root equal to a negative number. Remember, that can't happen. Doesn't matter what you put under the radical. If you square root something, it's got to be positive. So this is a no-no. This tells me right away that the problem has no solution. So you could put the no solution symbol, or you can write the words no solution. Be on the lookout for square roots equaling a negative number. And you don't want to judge it until the rad is by itself. I'm not judging it from the beginning. I'm judging it once I have the radical all alone. Third one, I got negative 2 rad 26 minus n equals negative 14. Okay, yes, it's equal to a negative. However, look at what's blocking it first. There's a negative 2 still being multiplied in front. So it's tempting to want to say no solution, but you got to get the rad alone first. You want to divide both sides by negative 2. So I get 26 minus n equals negative divided by a negative is a positive. Now there's no more issue. Notice the square root is now equal to a positive number. So this problem we can keep solving and we're going to get an answer. I'm going to square both sides to get rid of the radical. So I get 26 minus n equals 49. And then I want to get n by itself. So I'm going to subtract 26. I get negative n. Make sure you carry the negative down. Equals 23. But that's negative n. I got to get rid of the negative 1 in front. So I'm going to divide by negative 1. N equals negative 23. And if you plug that back in and check it, this one's going to work. All right, so the next couple have just a couple more steps. Okay. So if we look at number 4, you got -8 minus, there's a ninja 1 right here you don't see. I'm going to put it in, which is being multiplied by that radical, times the square root of 3x minus 2 equals 5. I've got to get the radical alone. That's my first step before I touch anything underneath the rad. Well, SADMEP, I've got to undo this subtraction before I undo this multiplication. So you can't just subtract the -8 and the -1. Okay, you got to do it in order. Add the 8 to both sides. That's gone. Now I've got -1 times the square root of 3x minus 2 equals 13. Still not going to square both sides because I still have this -1 blocking. I'm going to divide by -1 to get rid of that. And I get rad 3x minus 2 equals -13. This is the step where I pause. I'm even going to write that. Pause. And I look at it. I have a square root all by itself, and it's equal to a negative number. That can't happen. That looks exactly like what I have right here. I have a square root equal to a negative. That's a no-no. This problem has, I'm going to put the sad face again, very sad, has no solution. Okay. And maybe you don't, let's say you don't see that. Let's say that you just keep going through this problem and you get a value for x. You will. You could get an answer, but then the problem is when you plug it back into the beginning, what's going to happen is you're not going to get a true statement when you plug it back in. So whether you see no solution right away at this step, or you don't see it right away, you get a value for x. Once you plug it back in, you're going to get a false statement when you type it into both sides, or you plug it into both sides. So you'll get no solution no matter what. But be on the lookout for this. This is a nice clue that you have no solution. Okay. Last one on this page says -2 equals 6 minus 2 times, I'm going to put the dot, so you can see it, the square root of 2x plus 10. Just like in the last one I did, it's very tempting to want to subtract 6 and 2, but you cannot subtract because otherwise you are breaking the order of operations. Okay, don't break PEMDAS. So what do I do first? I get rid of the addition. I have a 6 that's positive, so I'm going to subtract 6 from both sides to get rid of that. -8 equals -2 times rad 2x plus 10. Before I square both sides, I need to get rid of that -2 in front. So I'm going to divide by -2. Get 4 equals rad 2x plus 10. Okay. So this is the stage where I examine it. I have the rad all by itself, and it's equal to a positive number. Happy face this time. That's good. I just don't want the rad to equal a negative. So now I square both sides to get rid of the radical. So I get 16 equals radical is gone. This is just exactly what you see underneath the rad. 2x plus 10. And I solve it like a normal equation now. -10 minus 10. 6 equals 2x. And then divide by 2. So I get x equals 3. Plug it back in, check it. And this one you'll notice will work if you plug it back in. Okay. So they're all kind of, they're kind of the same type of problem every single time so far. It's just the ordering of steps that kind of changes a little bit based on if you have addition or subtraction. So why don't you try out a couple before we move on to some longer ones. Here's what I want you to do. This is your turn to have some fun with these rad equations. You're going to try out number 6, number 7, and number 8 on your own. Hey, I will put answers on the screen without work. And if you want to see detailed work, you're going to go to the Google Doc and take a look at my filled-in copy of the notes, which has the work shown. So pause me, try these 3 out, and then we'll continue. Okay, so for number 6, you should have gotten no solution. For number 7, you should have gotten 18/7. Okay, fractions could be possible as your answer for these. And number 8, you should have gotten x equals 13. Again, if you did not get those 3 answers, go to my Google Doc, take a look at the filled-in steps. My guess is you probably just forgot a negative sign, or maybe you added when you were supposed to subtract. It's probably a minor error that you can fix by looking at it. If you're still confused after looking at that, log into the office hour or shoot me an email, and we'll definitely get that cleared up so that you're feeling good about these. All right, so the last portion of this lesson deals with what are called, the way we pronounce this word is extraneous. And you'll notice a word in there, extra. So we're kind of looking at something called extra solutions, extraneous solutions. So sometimes what happens is when you get the radical all by itself and you square both sides, you're actually going to end up with something that's quadratic, right? That's one of our favorite type of functions. And remember what that means is there's going to be an x squared in the problem instead of just an x. Whenever you have a radical equation and quadratics show up, 90% of the time you're going to get more than one solution when you solve it. That doesn't necessarily mean both answers are correct. This is why it's so important that you plug your answers back in and you check them. Whenever you get more than one answer, you need to test for what are called extraneous solutions. And what is an extraneous solution? An extraneous solution is a solution which does not make the original equation true. Okay, so doesn't satisfy just means makes the original equation. It's always going back to the original one. It makes the original equation false when you plug it back in, which means we don't want that as an answer. Think about it as like you go to the store and you buy a certain amount of items that you need. Maybe you bought 2 gallons of milk instead of 1 gallon of milk, and then you get home and you realize, oh shoot, I didn't need this extra gallon of milk. So you try to take it back to the store. They probably won't accept it. But that's like extra. You bought an extra item that you don't need, so you just toss it out, you throw it out to the side. Hey, that's an extraneous solution. Okay. So I'll show you how to test for those. Let's look at an example. Example 1 asks us, tell which solutions, if any, are extraneous for the given equation. So here's the equation they give you. X equals rad 28 minus 3x. And this one, they're not even making you solve the equation yourself. They're literally telling you what the two answers were that they got. They got 4 and they got -7. So what you got to do is you got to test both of those to see if they make this equation true or if they make it false. So in this box, I'm going to test 4. And in this box, I'm going to test -7. Let's see what happens. Testing 4 means everywhere that I see the letter X, I'm just going to replace it with the number 4. So I get 4 equals the square root of 28 minus 3 times 4. And then I simplify both sides. Square root of 28 minus 12. You don't do the square root until the end. You got to do everything underneath first. 28 minus 12 is 16, and the square root of 16 is 4. So this is the most important part. You look at the statement. Does 4 equal 4? True or false? That is true, which means that is an answer we want. So x equals 4 is not an extraneous solution. Extraneous means it's garbage and we throw it out. So x equals 4 is not extraneous. That would be an answer that we would circle in this problem. Let's try -7. All I'm going to do is the same thing, except everywhere I see x now, I'm going to be subbing in -7. So -7 equals the square root of 28 minus 3 times -7. I'm going to do everything underneath the radical first. 28 plus 21, negative times a negative. This is rad 49. And that's a perfect square. The square root of 49 is 7. So you look at that statement and you ask yourself the big question, why don't you change colors? That's not the big question. Does -7 equal 7? No, it doesn't. -7 is a negative number and +7 is a positive number. This is super false. Which means if I was doing this in a problem myself, that means I'd be crossing off x equals -7, which tells me x equals -7 is extraneous. It means it's an extra answer that I have to get rid of. It does not make the original equation true. So this one I'm just going to highlight the is. It is extraneous. It's a garbage answer. You take it back to the store, you say, excuse me, I'd like to return x equals -7. And they tell you, that's fine, but we're going to charge you a fee of $3.14. Okay, sorry for the bad joke. All right, before we do another one, I'm going to highlight this. This is real important. Make sure that you test your solutions to see whether or not they're extraneous. The most important time to check your answers. We've already seen the case I told you earlier where the square root equals a negative. That immediately cues you in that you have no solution. But when you're solving these quadratic ones, what's going to happen is you're going to get 2 answers, or you're going to notice the variable pops up twice in the problem, once on each side. If either of those 2 things happens, you're going to want to make sure that you check the problem for extraneous solutions. Okay, you get 2 answers to the problem. And that's going to happen whenever the variable shows up once on each side. So for example, here's number 2. Solve the following equation. X equals rad x plus 12. Immediately I notice there's an x on the left and I notice there's an x on the right. Okay, so variable shows up twice. I'm going to follow the same steps that I did from here, but I'm just going to realize, ooh, I might get some extraneous solutions for this one. I'm going to have to check. My first goal was to get the radical alone and then square both sides. So I check. Is the radical alone in this one? That's my first step. Okay, it is. There's nothing blocking it. So I'm going to move on to step 2, and I'm just going to square both sides. So x squared this time, and then the radical will disappear on this side. I just get x plus 12. Okay, notice we have a quadratic friend on the left, x squared. So you got your techniques you can use to solve this. You got either square roots, you got zero product property, or you got quadratic formula. Square roots is out because there's an x term. So I'm just going to, regardless of which of these I pick, I know I need to get 0 on one side. So I'm going to subtract x, and then I'm going to subtract 12. And you can do that in one step if you want. I'm just going to do it in 2. So I get 0 on one side, get my quadratic. And I'm going to try to factor it. The numbers are pretty small. I'm not going to waste my time with quadratic formula unless the numbers are real big. Wonderfully for us, the lead coefficient here is 1, so I can use my shortcut. If I get the magic numbers, what multiplies to negative 12 and what adds up to the b value, which is, got a ninja 1 right here, negative 1. And magic numbers to make that work would be negative 4 and 3. So one of my parentheses sets would be x minus 4, and the other one would be x plus 3. And then I use my zero product property. Either this factor equals 0, or other option is this factor, x plus 3 is equal to 0. And if you solve those, I'm going to add 4 to this one on both sides, so I get 4. And I'm going to subtract 3 from both sides on this one. I get negative 3. Okay, I see 2 answers, which I kind of knew that was going to happen because of the fact that I had an x on this side and I had an x on this side. That didn't happen on the first bunch of problems we did today. So this is why it's real important now. You got to check your answers. So what I'm going to do is I'm going to check this one by plugging it back into the original. And I'm going to check this one by plugging back into the original. What do I mean by original? The original problem is the one that I had right at the start before I squared anything. So the one that was written on paper before I started writing. So I'm going to be testing it back into the equation x equals rad x plus 12. Uh-oh, 10. It's real important that you're using the original. You don't want to plug it back into the equation after you squared it, because otherwise it's going to be true every time. So I'm plugging it back into the original. Everywhere I see x, the first time I'm going to try 4. 4 equals the square root of 4 plus 12. That means 4 equals the square root of 16. Hey, the 4, or the square root of 16 is 4. Does 4 equal 4? True statement. That means I can circle this as an answer. This works. So I circle that one. I'm going to highlight it to make it clear that that is not extraneous. That is an actual answer to this problem. But now I also need to check negative 3. So I'm going to test it the same way. I'm testing it into the original equation. And everywhere I see x this time, I'm replacing it with negative 3. Negative 3 equals the square root of negative 3 plus 12, which would be the square root of 9, which is positive 3. But wait a second, this here says that negative 3 equals 3. That's not true. Negative 3 does not equal positive 3. That tells me that this solution right here is extraneous. So what do I do with an extraneous solution? I cross it out. I don't circle it. It means I block too much. Okay, so the only answer to this problem is 4. This one is extraneous because it makes the original equation false, whereas this one made it true. All right, last page. Let's try a different one. Solve the following equation. We have 5x equals the square root of 4x squared plus 63. I notice that there's an x on the left side and there's an x squared on the right side. That still counts as a variable. So this is probably going to be a problem where I might get an extraneous solution. I'm going to have to check. My guess is I'm going to get 2 answers. First thing I want to make sure I have is the radical is by itself. Is there anything blocking the radical outside? And in this one, there isn't. So all I'm going to do is square both sides to get rid of that rad. Notice I'm not just squaring the x this time. I have to square the 5 also. So I'm going to get 25x squared instead of 5x squared equals, and the rad will go away now. I'm just going to get what's underneath, 4x squared plus 63. Okay, looks quadratic to me. So I look at my checklist. I can either use square roots, zero product property, or quadratic formula. And I say we use square roots on this one because there's no x term. It's just x squareds. So I got to get my x squareds on one side. I'm going to move them to the left where it's positive. I'm going to do that by subtracting 4x squared on both sides. 21x squared equals 63. I'm just solving it like a normal equation, and I'm going to take care of that square at the end. So I'm going to divide by 21, get x squared equals 3. But notice it's x squared, so to get rid of the square, you got to square root both sides. Whenever you square root both sides of an equation, you get two possible answers. This could be rad 3, or this could be negative rad 3. And when we were doing this in chapter 9, I used the plus or minus symbol, but I'm writing it as two separate answers this time just because I know I'm going to have to check this one and I'm going to have to check this one. And there's a chance I might cross one of them out. So the first one I'm going to check is x equals rad 3. And then I'll check x equals negative rad 3. So I'm going to type it into the original equation or plug it in. 5x equals the square root of 4x squared plus 63. Everywhere I see x, I'm going to replace it with rad 3. 5 times rad 3 equals the square root of 4 times rad 3 squared plus 63. This 5 rad 3 just keeps coming down. Okay, can't do 4 times rad 3 until you square the rad 3. What's rad 3 squared? That's just normal 3. So I get 4 times 3 plus 63, which is 4 times 3 is 12. 12 plus 63 is 75. If you break down rad 75, that's rad 25 times rad 3, which, hey, that is equal to 5 rad 3. So this one works. 5 rad 3 equals 5 rad 3. Check. So I circle this one. This one's an answer. Now I do it with negative rad 3. Everywhere I see x, I'm going to replace it now with negative rad 3. So I get 5 times negative rad 3 would be negative 5 rad 3. See if I have room. Equals the square root of 4 times negative rad 3 in parentheses squared plus 63. Negative 5 rad 3 equals, if I square negative rad 3, it's still going to be positive 3. 4 times 3 plus 63. It's the same thing we had over here. Squaring the negative still is positive. So this is going to be 75, which we already broke down before. It was positive 5 rad 3. This is an issue. Can't have negative 5 rad 3 equal to positive 5 rad 3. False. That means that this is an extraneous solution. So what do? It means we cross it off. This is not an answer. This is why it's so important that you check. If you don't check, you're going to give 2 answers when there should only be 1. Okay? So x equals rad 3 is the only solution. X equals negative rad 3 is an extraneous solution. You throw it out. Okay, we'll do one more together, and then there's one you try at the bottom that you're going to do. All right, so we're going to solve x equals the square root of 2x plus 3. First thing I notice is that there's x's on both sides, so this is probably going to be a problem where I get 2 answers, and I'm going to have to check them to see if one of them is extraneous. So radicals by itself, I'm going to start by just squaring both sides. So I get x squared, and then the radical on this side will disappear. So it equals 2x plus 3. Checklist, I got square roots, ZPP, and quadratic formula as my options. I say square roots is out because we have an x term this time, not just x squareds. Regardless of which one I choose from the remaining list, I'm going to have to get 0 on one side. So I'm going to subtract 2x from both sides first. It's gone, so I get 3. but I need 0, so I got to subtract the 3 over as well. So I get x squared minus 2x minus 3 equals 0. Numbers are small, so I'm going to try to use zero product property by factoring. What would multiply to -3 and what would add up to -2 in the middle? And your only option there would be either -3 and 1 or 3 and -1. And we need it to add up to -2. So -3 and 1. Lead coefficient is 1, so I can just use my shortcut. X minus 3 times x plus 1 equals 0. So my two equations would be x minus 3 equals 0 or x plus 1 equals 0. If you add 3 to both sides, this one gives you 3, this one gives you -1. Two answers. Don't circle them both right away. You haven't even checked them yet. So the first thing I'm going to do is I'm going to check x equals 3. And then I'm going to check x equals -1. So you plug it in. I'm just going to use the original equation, not using any steps that I played with. I'm going to just do the one that I started with. So I'm going to plug 3 in for x. 3 equals the square root of 2 times 3 plus 3. 3 equals the square root of 6 plus 3. Just keep simplifying the right side. Square root of 9 is 3. 3 equal 3. True statement. Means this is an answer, not extraneous. It worked in the original. Now I go and I try -1. Everywhere I see x, I'm replacing it with -1. So I'm using the same equation. This time I'm going to plug in -1. -1 equals the square root of 2 times -1 plus 3. -1 equals the square root of -2 plus 3. -1 equals the square root of 1. The square root of 1 is 1. Does -1 equal 1? No, it doesn't. So x equals -1 is extraneous, which means I cross it off. It is not an answer to my problem. Cross it out, doesn't count. So make sure that if you get two answers, you're going and plugging them in. That's one expectation, is that you're checking those answers. All right, the last one is for you to try. You're going to solve x equals rad 6x minus 9. So I'm going to let you do this one on your own. Once you're done with it, go check the document that I have posted. I have the answer in the filled in notes in the Google Docs, so you can check that. And if there's any questions, feel free to log in. We can talk through these on the office hour today or this week. Hey, have a good one. Happy ratting.